All right, so we're continuing the Chapter 1 practice test. We're looking at 16 through 31 in this video. Number 16, I'll do down here, is negative 9 times the quantity of 3n minus 8 plus 4n equals 5 times negative 2n minus 9. So we're going to distribute the negative 9. The negative is going to go with it. So we have negative 27n. Negative and negative make a positive 72 plus the 4n. And we're going to distribute the 5. 5 times negative 2n is negative 10n minus 45. And we're going to combine our like terms here. We have a negative 27n and a 4n. So that gives me a negative 23n plus 72 equals negative 10n minus 45. And I'm going to, let's see, add my 10n, because I now need to get my n's on the same side of the equal sign. So we get negative 13n plus 72 equals negative 45. And we'll subtract 72. Let's move this up a little bit while we're working. And we get negative 13n negative 117. And then we need to divide both sides by negative 13. And we get that. And so 13, let's see. I know that 3 times 9 gives me 7. So let's look at 13 times 7. That's, 13 times 9. That's 27. 9 plus 2 is 11. So n equals 9. On the test, I kept the numbers pretty manageable, so it shouldn't be like big numbers for you. So now we're looking at some absolute value equations, remembering that absolute value is always equal to a positive. If it's not, the absolute value by itself is not equal to a positive, it's no solution. And that the number inside can equal both the positive and the negative of what it's equal to. So number 17 is the absolute value of x minus 6 plus 2 equals 9. I have to get this absolute value isolated first, so I'm going to subtract the 2 from both sides of the equal sign. I get the absolute value of x minus 6 equals 7. Now what we know is what's inside the absolute value, the x minus 6, oops, let's go to a pen, can equal positive 7, or x minus 6 could equal negative 7 because it's inside the absolute value. The absolute value of the negative 7 is 7. So now I can add my 6. So x equals 13, and I can add 6 here, or x equals negative 1. Number 18, I have 6 times the absolute value of 9x plus 5 equals 18. Again, I need to make sure that I get this absolute value by itself before I can do anything with what's inside. So we're going to divide by 6, because this is multiplication, 6 times the absolute value. So we get the absolute value of 9x plus 5 equals 3. Now what's inside the absolute value, the 9x plus 5, can equal positive 3. Sure, I keep doing that. 9x plus 5 can equal 3, or 9x plus 5 could equal negative 3. Let's move this up and give us some space here. And now we can subtract the 5, right? Minus the 5. We get 9x equals negative 2, and 9x equals negative 8. And uh-oh, it doesn't go in evenly. divide by your 9, because that's multiplication, and the inverse is division. So x equals negative 2/9. It's a completely reduced fraction already. I don't need to make it a decimal, just leave it as a fraction. Just make sure if you had like 16 over 18, you reduce it by dividing by 2 to get 8 over 9. Okay, so don't leave it unreduced, but you can leave it in a fraction, and you can leave it improper. Number 19. Let me move some of these things out of the way. Make some space here. Number 19. Negative 8 times the absolute value of 7x minus 1 minus 3 equals negative 51. And we're going to, again, the goal is to get that absolute value by itself before we can write our two equations. So we're going to add the 3. We're going to undo the addition here, subtraction. And negative 8 times the absolute value of 7x minus 1 equals negative 48. Still looking to get the absolute value by itself, so we're going to divide by negative 8. Because remember, this is negative 8 times the absolute value. I'm not going to add it, I'm going to divide it. And I get the absolute value of 7x minus 1 equals 6. Now the absolute value is equal to a positive, so there's going to be two answers. We get that what's inside 7x minus 1 could equal 6, and it could also equal negative 6. So we have these two equations, and we can solve them. So there's our absolute or equal sign. We're going to add 1, and 7x equals 7. Divide by 7. So x is equal to 1. Or add 1. 7x equals negative 5. Divide by 7. And x equals negative 5/7. And again, I can just leave it as that fraction. Number 20, absolute value of x divided by 3 equals 3. So there's nothing outside the absolute value. It's already by itself here. So I can just write my two equations. What's inside x over 3, x divided by 3, could possibly equal 3, or x divided by 3 could equal negative 3. We solve that division by multiplying both sides by 3. Take note of how I'm showing my work. That's what we expect for you to see, to do, and expect to see when we're grading your tests. Multiplying both sides by 3. This is really multiplying by 3 over 1, and that's why these cancel. And we get x equals negative 9. That's number 20. Number 21. Absolute value of 7z minus 5 equals 3. Again, the absolute value is already by itself, so I can just write my two equations. 7z minus 5 can equal 3, and 7z minus 5 could equal negative 3. And then you solve your two-step equations here. Add your 5. You get 7z equals 8. I'm going to add my 5 here. I get 7z equals 2. And divide by 7. And z equals 8/7. And, or, it's not and because it can't be both at the same time, so it's one or the other at each time. Or z equals 2/7. These are kind of backwards, but if we have a simple problem here, the absolute value of m is equal to negative 7 here. Absolute value equals a negative. Well, absolute value means a distance from 0. And distance is always positive. So what could we put in here that would make it come out negative? Nothing. So this answer is no solution. Then we have the absolute value of z minus 9. It's by itself, so I can write my two equations. Z minus 9 equals 5, and z minus 9 equals negative 5. We can add 9 to both sides. So z equals 14. And I can add 9 here, and z equals 4. So z equals 14 or 4. And 24 here, we have the absolute value. Again, it's by itself and it equals a negative. That can't happen because it's always positive, so this one is again no solution. Number 25 here. Move these over so I can just work under this. Negative 9 times the absolute value of negative 5 ninths w plus 7 minus 8 equals negative 26. Now I know you might recognize this negative over here, but that doesn't mean anything until the absolute value is by itself. So we're going to work again. Get this absolute value by itself by adding 8. And we get negative 9. Absolute value of negative 5 ninths w plus 7 equals negative 18. And then we can divide by the negative 9 to get the absolute value by itself. And it equals a positive 2. Now we're positive, so we can have answers. And we'll write our two equations. What's inside? Negative 5 ninths w plus 7. Notice I'm copying what's inside exactly the same. Equals 2. And negative 5 ninths plus 7, exactly the same equation, equals the negative 2. Nothing from inside the absolute value changes. And then we solve our equations. Now this one has a fraction in it. But first we're going to move the constant. We get negative 5 ninths w equals negative 5. And we get negative 5, forgot the w there, ninths w equals negative 9. And to get rid of a fractional coefficient, we're going to multiply by the reciprocal negative 9/5. So w, the 5's cancel, that's 5 over 1. 5 divided by 5 is 1. So I get negative 1. I get negative 1 times negative 9, which is positive 9. And we're going to multiply by negative 9/5 on this side. And we don't have any canceling going on, so w equals, put a 1 under it, multiply the numbers on top. Negative 9 times negative 9 is 81. 1 times 5 is 5. So we have 9 and 81/5. And it's okay if you get fractions as your answer. Those are simplified. I can't do anything with that. Okay, so I'm going to move this one out of the way so we can do this one, these two. Now we're just going to solve them, and then if there's a solution, we're going to state it. If there's not, we want to determine whether it's no solution or infinitely many. So 5w minus 9 equals negative 13 plus 5w. We want to get the variables on one side, so I'm going to subtract 5w. And 5w minus 5w is 0, so that zeroes out. And that zeroes out. I'm left with negative 9 equals negative 13, which is a false statement. And when my variables disappear and I get a false statement, this is no solution. Let's look at number 27. Negative 7 times 9y plus 5 equals negative 35 minus 63y. So I'm going to distribute my 7. I get negative 63y minus 35. equals negative 35 minus 63y. Looks like both sides of the equal sign are the same. So if I add my 63y, these zero out, and we're left with negative 35 equals negative 35, which is true. And that means it's infinitely many solutions. And the last four, solving the literal equations for y or x. So the first equation, negative 4x plus y equals 10. I'm going to solve for y. So that means I want to move the 4x. So add 4x to both sides. So y equals 4x plus 10. I like to put my variable first because that gets us in the mode for when we get to graphing in slope-intercept form. 29. Negative 24x minus 27 equals negative 8y plus 5. Again, my goal is to get y by itself. So first I'm going to move my 5. I get negative 24x minus 32 equals negative 8y. Still working on getting y by itself, so that's negative 8 times y, so I'm going to divide by negative 8. And we get 3x plus 4, negative makes positive, equals y. And that's my equation in terms of x, solved for y. Now number 30 has two x's on this side, and it wants me to solve for x, so I'm going to start by combining my like terms. K equals 23x. And then I want to get x by itself. So we're going to divide by 23. And we can say that x, or let's do the k first on this side. K over 23 is equal to the x. And then last one, 31. 3 equals 2x plus 8y. Goal is to get x by itself this time. So we're going to move the y to the other side first, minus the 8y. And 3 minus 8y equals 2x. Still working on getting that x by itself. So we'll divide everything by 2. And when we do that, we get x equals, well, let's see, 3 halves minus 4y equals the x. And that's our final answer.